Hi, my name is Stacey Hurd, and I conducted my Applied Exercise and Sports Physiology manuscript on the internal and external pacing strategies associated with long-distance cycling. Athletic performance is dependent on a wide variety of physiology and psychological factors associated with both the individual and the sport involved. Such variables include heart rate, oxygen consumption, respiratory exchange ratio, and the total expiration volume, or VE. The ability to win or lose a competition comes down to the ability of an athlete to perform at their optimum intensity. The regulation of energy expenditure is a crucial aspect of peak performance. This regulation can be controlled through the use of various pacing strategies. The wide variety of physiological data produced through the use of pacing strategies can be relayed to athletes in a variety of ways. For the purpose of this experiment, only internal and external pacing strategies will be discussed. External strategies are those that relay data to athletes via visual or verbal cues. Internal strategies provide no feedback to athletes. They must rely on their own ability to interpret what their body is trying to tell them. Choosing the right pacing strategy is the key. However, this is made difficult by all the associated variables, such as the type of sport, the length of the event, and the competitiveness of the athlete, just to name a few. Strategies may need to change over time as an athlete's performance level increases and decreases with age, injury, environmental conditions, etc. The purpose of this study was to determine whether there is any significant difference in athletic performance when utilizing internal and external pacing strategies during a 4-kilometer cycling time trial. A randomized crossover study was conducted on 10 Central Queensland University exercise and sports science students, ranging in age, height, weight, and gender. Each participant took place in 2 4-kilometer cycling time trials on a Velotron cycle ergometer. Heart rate monitors and portable gas analyzers of the Oxycontin brand were used to collect continuous heart rate and oxygen uptake data. Figure 1, as shown here, shows the setup of the external pacing strategy, where the participants are situated in front of a television screen that shows a list of their physiological data in real time in order to help them regulate their performance throughout the trials. During the internal strategy time trial, the television screen was blank and no verbal feedback was given, so the athletes were completely alone in creating a suitable pace. After a short warm-up, participants were instructed to start whenever they were ready and to complete the trial in the fastest time possible. All participants completed their first trial, either with or without feedback, due to the randomized order of the study. The second round of trials were completed by the participants in the same order as the first, to ensure equal resting times between the trials. Data was later analyzed using a 0.05 alpha level throughout a series of 2 sample t-tests. F-tests were conducted to determine if equal or unequal variance t-tests were required. Once determined, these t-tests were conducted on the 3 variables RER, VE, and split times to determine if any difference existed between the 2 strategies. The p-values of every t-test conducted produced scores that were higher than the proposed alpha level of 0.05. This resulted in the null hypothesis being accepted, that there was no significant difference in athletic performance for the 2 pacing strategies when using the RER, VE, and split times as the determining factors. The 4-kilometer time trials showed no significant difference in RER, VE, or split times between the 2 pacing strategies, either over the length of the study or when averaged over each kilometer interval. This data is conflicted with previous studies conducted on the subject. There are many variables that could have affected the data, such as the small participant group, participants being unaccustomed to the equipment being used, or the competitive nature of the sports students used. Guy et al. described that the most efficient pacing strategy implements a fast start, followed by a constant power output at a reduced level. This allows for enough energy to speed to the finish line. One major problem observed in relation to the external pacing strategy during this study was that participants did not look up at the television often enough to get the full use of the data being presented. When looking at the raw data, participant finishing times were faster during the external pacing strategy compared to the internal one. Therefore, some difference does occur between the two strategies. It's just an insignificant one at this stage. This study showed that athletic performance produced no significant difference when implementing the two different pacing strategies. Unexpected data was produced. However, with further experimentation, this data could be corrected. Optimizing athletic performance is crucial to create elite athletes. Coaches need to tailor pacing strategies to the individual athlete and the sport that they are involved in. The best way to find the right strategy is to take the time to test out a variety of strategies until performance is significantly increased. If you wish to read more on the subject, the following references should help you get a larger grasp on the efficiency of pacing strategies. Thank you for your time.